7.1. I'm going to be flipping back and forth between my book and the student book because I'm not going to be taking too much time to write some stuff down. So if you need to pause the video to finish writing some of this stuff down and read through it, make sure you do that. So hopefully this will be a little more clean for you guys. So we're going to definitely hit some things. Rational functions is one thing we're going to define, and vertical asymptotes is another thing we're going to talk about. And we're going to go back over horizontal asymptotes and make sure we have those understood. So, all right, so here we go. So the first problem says recall, and you can read through all this. Recall this. The big thing is reciprocals. Remember, when we have reciprocals, they multiply to 0 or to 1. So like 5 and 1/5 are reciprocals because if you multiply those, that equals 1. So that's what this is talking about. So when we do these guys, we're talking about something that's going to look like this, where this can be a function and this can be a function. And we're going to get to that more later on, just kind of talking about it to start off with. So here we go. To begin answering this question, first they're going to talk about, let's look at the, this is x. This is one graph, which is where y equals just x. So that is my function, y equals x. That's this one right here. And this one is where they take the reciprocal of it, where y equals 1 over x. And remember, they're talking about g of x because it is a function. So they graphed f of x right here. And what we're going to do is when we go to the other page, they're going to fill this all in, and they're going to fill this all in, and they're going to fill this all in, and we're also going to see some graphs of those, and it's going to be the reciprocal of this linear line, of this linear equation. So what they're going to do is, and I'll fill this first one in and show you how they get it. They say, okay, y, or g of x, equals 1 over x. Well, what is my x value for this box? It's 1. So 1 over 1 is 1. So that's how they get a 1 there. They're going to then take 2 and plug that in. Well, when you plug 2 into right here, you get 1/2. When you plug 3, you get 1/3, 1/4, and so on. So if we go to this other page, so when I switch to this other page, they filled all those boxes in by just taking the x and plugging it in. That's the same thing that they did right here. They just took -6 and they put it, so it's -1/6, negative, so that's how they got this. And then right here, they took and they plugged in, so they plugged in -1. Well, when you plug in -1 down there, you get -1 because you have a -1, or 1 over -1. So right here is where I'm talking about this box. Right here, they actually take, in here, they plug this in. They get 1 over, I'm in this box just so you know, they get 1 over, what does x equal? A -1/2. Well, what happens when you plug that in? That becomes really a 1 over 1 divided by, see, 1 over 1 divided by a -1/2. Well, we don't like to divide by fractions. We take this, we keep, change, and flip, so it becomes a 1 over 1 times a -2 over 1. Well, when you do that, you multiply these, multiply top times top, bottom times bottom, you end up with a -2. That's how they ended up with the -2 here. And so forth with all of these other questions, or the numbers. So you can pause and take a minute, fill that in. And then what they did is they just graphed this. So they said, in order to get g of x, which is in red, g of x is right here, there's 2 sections of this graph. You can see it's right here, and it's right here. And all they did was they used this x and this y and plugged those in. This x and this y. This x, this y. And they plotted all those points up here. And when they did, they got 2 sections. And you're going to notice some of the things. So we're going to get into more graphing of that later on. But that is definitely how all they did is they just put this x and this y. 1, 1 should be an ordered pair. So if I go over 1, up 1, you can see it right there. 2, 1/2 should be. So go 2 and 1/2, and you can see that ordered pair right there, and so forth. But notice, we're going to talk about some things with this graph that will never ever happen. That's the idea of asymptotes. So we'll get there in just a little bit. But that's completed the table. All right, so we're going to go through some problems. So it said describe the graph g of x. How is it similar to the other functions you studied? How's it different? So you might say that this graph is similar to quadratic because it's curved. The graph is different because I've seen in the past, now this thing has two different pieces, whereas before they've only had one. The graph is different because it doesn't look like it touches the x or y axis. The behavior is similar to exponential functions, so we're going to talk more about those things. Describe the end behavior. So this is definitely key right here. Describe the end behavior. All right, so as x approaches negative infinity, so as this graph is going left, y is approaching 0. That means that your y is getting closer and closer and closer and closer to the 0. As x goes to positive infinity, or as it goes right, you notice that it is also getting closer and closer to 0. So if I go back up here to this graph, you notice as my graph is going left, I'm getting closer and closer to be 0, but it's actually never going to touch. I know my marker looks like it's touching. It's just a fat marker. It will never, ever touch this line, guys. Same with this. As I'm going to the right, this graph right here looks like it's getting closer to y being 0, but it's not. It is getting closer, but it's never going to touch it. All right. Describe g of x as x approaches 0 from the left. All right. Explain each output. Explain the output behavior of the function in terms of the equation. So, as the function g of x is decreasing, because what's happened, let's go back for a second. Describe x approaching 0 from the left. So as I'm going, so from the left, that would be this side of the graph, as it's coming to here, what do you notice about this? It's going down forever. So as I'm going this way, as I'm going to the left, I'm still continuing going left, my graph is going down infinitely. So when they go to that answer, they're going to say, the function is decreasing. That means that my y is going down. But then all of a sudden, it's like the graph, you jump. So that's this idea of asymptotes. Let's just go there real quick. The idea of asymptotes is all of a sudden the graph gets to a certain point, and it jumps over it, and the graph can totally change behaviors. So right here, there's an asymptote, which means that it will never ever touch that line. It'll get as close as it can to that line, but it won't touch it. It won't go across it. It actually has to jump across it. So you'll see that this graph here, and then all of a sudden it goes to there. So there's an asymptote here, and there's an asymptote here. This is called a vertical asymptote, and this is called a horizontal. We will talk about how to find those in a lot more depth here very soon. But these guys are never ever going to be touched. So as I'm going closer, as my graph is going left, you see that all of a sudden it takes a turn down, and this thing is going down forever. But from the right, as I approach, so as I'm going to the right, so I'm going from this way, and I look back, my graph is going up infinitely. So those are going to be two ideas that they're going to talk about. So as it approaches from the left, as I'm approaching this 0 from the left-hand side, it goes down to negative. So the y is decreasing. As I approach it from the right-hand side, though, my y is increasing. So that's the E question. So we just discussed these guys. As it's approaching from the right, okay, the function is increasing. That's what we just talked about. All right. Henry and Rosie disagree about the g of x. The graph and the table both clearly show that it is a function. Rosie said it is not a function. Every input doesn't have an output. Well, Henry is correct because each graph does not have to have, every input does not have to have an output. We just cannot have more than one output for every input. Remember, it's the idea of the vertical line test. Well, if I go back up here, I know I'm going back and forth, I'm sorry. If I go back up to this guy and I draw vertical lines, use green. If I draw vertical lines, this graph never ever touches that. I know right here it looks like it does, but we got to understand, you got to zoom in way tight, and you can see that this graph is barely going over, and it's never ever going to be. Same here. It never touches any, the same x does not have two different y outputs. So it is a function. And we already know that it is a function. One of the other reasons we can tell them that it is a function is because it's written in function notation. So we know that it's a function. All right. Analyze the key characteristics. Will the graph ever intersect the y equals 0? Explain your reasoning. No. The graph will never intersect the line y equals 0. You can see this in the graph, you can see this in the table, but let's just make some sense of this. If we have g of x equals 1 over x, you are plugging in, every time you make an x in a y chart, you are plugging in x in here. So what happens is, when we plug in 1, we get 1 out. When we plug 2, we get out a half. So we can see all those things. Well, when we plug in 0 here, okay, when we plug in 0, we end up with 1 divided by 0. And from a long time ago, you should understand, you're not allowed to divide by 0. That is called undefined. You're not allowed to have that happen. So it's not an answer. There's no answer there. Let's put undefined there. So undefined. This would be undefined. You cannot have that. So it will never ever be 0. So the y, remember they're asking, will this ever equal 0? Can I ever get a 0 out? No, because there's no way to make this bottom 0. And the reason it has to do with that, let me go back actually. Let me make this. Let me do a better job of explaining that with this. In order for a fraction to be, for my output to be 0, in order for my y, we'll hold on to this for a second. In order for my y to be 0, if a fraction, this is how much I have. So in order for a fraction to ever become 0, you would have to be able to make the top 0. Well, is there ever a way for me to make this top 0? No, because 1 is always a constant. Now, so there's never a way for my output to be 0 because I always have something. I have 1. Now, it might be really small. I can get 1 over a million, and yeah, it's tiny, but I've still got something. I've got a little tiny chunk of a million. So this will never ever, my output can never ever be 0. Because I have something in the top. The top will never be 0. Now, if I can make the top become a 0, then my output can become 0. But right now, with this just being a constant, there is no. Now, the B part is where I actually plug in 0 for x, and when you plug in 0 for x, you get 1 over 0, which is an undefined. So actually, B was the one I'd explain first. Sorry. So hopefully you understand that. If you have some questions, make sure you ask me tomorrow in class. Write some questions down. It's okay for you to write all over this book. You should be pausing these answers, writing them down. They're nice and easy for you to read. So describe the domain and range. The domain and range is everything that x can be. Well, we just talked about it. If I look, my x can be any number except for 0. So the domain is all real numbers except 0. My range is very similar. All real numbers except for 0. And if we look back at my graph, that makes sense. If I look back at my graph, this thing never ever stops going this way. It never ever stops going this way, which I'm talking about left and right only, which is domain. I'm talking about the domain, except there's one spot that it jumps over, which is the asymptote at 0. So it's all real numbers, except x can't equal 0. It's not allowed to equal that. And the same with the range. If I look up and down, Does this thing ever stop going up? No. Does it ever stop going down? No. But there's one spot it jumps over. And so it would be all reals except y cannot equal 0. Alright? Alright, so now we're getting into some things. So rational function is any function that can be written as a ratio of two polynomials. Basically, all you have to understand is a rational function is where you have an equation in the top and an equation in the bottom. But they have to be polynomials. And so that's why they call it P of x and Q of x, because this is just a equation in the top, equation in the bottom. Now, those things can be linear, they can be quadratic, they can be cubic, they can be higher order, which means fifth, sixth, anything like that. And so what happens is when you have these guys, you have two things that can occur. You have one thing which is called a vertical asymptote. A vertical asymptote is where the denominator equals 0. Because what happens is when you divide by 0, you have that undefined thing happening. So whenever the bottom becomes 0, you have a vertical asymptote. That's not allowed to happen. So we're going to find out how to figure those guys out, but you can see an asymptote occurs, the input value results in the denominator being 0. That's what you really need to focus on, vertical asymptote and that idea. And horizontal is a little different. We're going to talk about it real quick. So to find horizontal asymptotes, you go like this. You have f of x, and it equals some function on top, which will look like this, with an a x to the m power plus dot dot dot, because maybe there's more stuff after it. And you've got b x to the n plus dot dot dot. So basically what you're doing is, for this, m is going to be your highest power of your top, and n is going to be the highest power of your bottom. And what happens is we've got different cases. So first, if n is less than m, that means your bottom power, the highest one, is smaller than your top. Then you automatically know you have an asymptote of y equals 0, or what is known as the x-axis. You have this thing that will appear. 2, if n is equal to m, that means that the power on the bottom is the same as the top power. Then you have an asymptote at y equals a over b. And notice a is the coefficient of the highest power in the top divided by the coefficient of the highest power in the bottom. So that is where your horizontal asymptote will happen. And remember, y equals lines. Horizontal means these are all lines that are going across straight like that. And 3, if your bottom is bigger than your top, then there is no vertical or no horizontal asymptote. No horizontal asymptote. Now, there might be vertical asymptotes, there might be slant, there might be obliques. These are things we'll come up with later on, but there will be no vertical asymptotes, or horizontal asymptote, which means there's no line that would be going across. So here we go. And yes, we will be, for asymptotes, we will be using dashed lines. That's huge. If you see a dashed line on a graph, that means that it is an asymptote. So like right here, you can see that this guy right here has a vertical asymptote, and the vertical asymptote is x equals 0. Remember, it's a vertical line, so it's an x equals, because everywhere I'm on this line, x equals 0. So that is an x equal. Whereas horizontals, you'll notice, are all y equals, because they're lines that are going right and left. All right, so here we go. Let me go back. All right, so they want us to analyze. They want us to circle the rational functions. So rational functions, they have to be basically a function over a function. And so when I do this, when I circle these, we're going to go back to the other one. All of these would be circled. All of these guys would be circled. So these guys, the only two that would not be circled are this one and this one. And the reason why is because h is not a function, a rational function, because we have a square root. Notice the square root is right there, which means that it is not a polynomial. And the n of x is not a polynomial because we have a variable as the exponent right here. X is to a power. So those two guys are not polynomials, so they are not rational functions. All right. Do you think the graphs of rational functions will have vertical asymptotes? All of them. No, not all of them will have vertical asymptotes. In order for us to have vertical asymptotes, I have to have a way of making the denominator 0. Hopefully you'll realize there's no denominator. That's still a rational function. It's actually going to be a linear, but it's still rational. I could write it as x over 1, which, yes, that is a polynomial. Yes, that is a polynomial. But that doesn't have a vertical asymptote because there's no way of making my denominator 0. Again, in this one, there's no way of making my denominator 0. No way of making my denominator 0. Yes, I can make that, so that will have a vertical asymptote. Yes, I have a way of making that denominator 0, so it will have one. And yes, I have a way of making that denominator. So vertical asymptotes, yes. If I wanted to look at this guy just for kicks, for horizontal asymptotes, remember my rules. My rule says that, so let's look at this one right here. I have x over 1. The power is x is 1. If I look here, there is no x, so if I wrote it in, it'd be x to 0 power, because anything to 0 power is 1. So if I look, my m is greater than my n. And if I look back, if n is, and I'm sorry, I need to go back up here and change something. My fault. Please change this. This is my fault. This should have been, will make a lot more sense. This should have been m, and this should have been n. So so on this one, if my bottom is bigger than my top, then I have this one. Sorry about that. Please correct that. That's huge. If they're still equal, it didn't really matter. If my top is bigger than my bottom, then there is no horizontal asymptote. And that's why I knew I made a mistake, because right here, my top is bigger than my bottom. So m is m is bigger than n. And if I look back at my rules, if m is bigger than n, that'd be the same thing. Oh, whoops, I'm going to change it again. Scratch. This is n. This is n. So if n is greater than m, there we go. There is no horizontal asymptote, which makes sense. So hopefully, if you go back up top, just switch the m and the n. That was my fault in where I put those. So the top is bigger than the bottom, no asymptote. So right here, let's go to this one. I look at my rational function. I got 3, which is x to the 0 power, and I've got x to the first power. Uh-oh. My bottom is bigger than my top. My bottom is bigger than my top. So that means this is n, and this is m. That means that n is less than n. And in that case, x equals 0 was a horizontal asymptote. This guy right here, if I look here, x is to the second power, x is to the third power. So my bottom is bigger than my top, which means x equals 0 is a horizontal asymptote. This has x squared on the bottom. How did I know that? Because it's not in fact, it's in factored form. I know that I'm going to have x times x, so x squared is going to be on the bottom. There is no x's, so it's x is 0, so again, my bottom is bigger than my top, so x equals 0 is going to be a horizontal asymptote. Alright, use a graphing calculator to explore describe the changes. So if you did this, if you put this into a graphing calculator, as your a value increases beyond 1, the graph of the function gets further from the origin. That means it gets further from 0, 0. As a value moves further from 0 in the negative direction, the graph moves in the second and fourth quadrant, but maintains the same shape as positive versions. When a is between 0 and 1, the graph is closer to the origin. All right. Abby and the top should disagree about a of x, where a is a constant. So if I have a constant, remember, if I have a constant, something like 5 over x. Remember, this is x to the 0 power. This is x to the first power. Which one is bigger? My denominator. If my denominator is bigger, then x equals and y equals 0 is going to be my horizontal asymptote. And all these, if I put x's, I'm sorry. I'm terrible. My brain farts today. These should be y equals 0. Not x equals. These are horizontal. Y equals, sorry about that. So, all right. List rational functions that do not have horizontal asymptotes at y equals 0. And they gave you a list right here. These are just things that they put in. And what do you know has to happen? In order for there to be no horizontal asymptote, your top power has to be bigger than the bottom. So you could have put x cubed plus x squared minus 3 over x squared. If you look at this, this is the third power, this is the second power, and your top is bigger than your bottom, so it will have it will have no asymptote, which is what they're looking for. All right. If g of x is a reciprocal of f of x, then what happens when you multiply them? Well, what do we say when something is a reciprocal? If you multiply those two, it should be the product should be 1, which is what they're trying to say here, because anytime you multiply reciprocals, they equal 1. All right. All right, so we're going to go through this one a little quicker. All they've done now is they've taken and made this x squared. And so they take x squared, and that's the blue line. This is going to be q of x is the blue. And then they go ahead and they do r of x, and that is in the red. So you can fill these in, whatever's not in your book. This is going to be r of x. And what they're doing here is they're showing you what happens when you graph these two. And here, I know that the graph will have x and y asymptotes at 0 because you cannot divide by 0. Again, for your vertical asymptotes, you're making the bottom 0. So if I put in x equals 0, if I put in x in a y chart, if I put in 0, I get an undefined. So that means that right there, my bottom is becoming 0, which isn't my vertical asymptote, which vertical asymptotes are going to be up and down. So that means that x cannot equal 0. And then if I look here, my top power, which is x is 0, is smaller than my bottom one, which means I know that y equals 0 is a vertical asymptote, or a horizontal asymptote. So this is my horizontal asymptote, this is my vertical asymptote. So if I look, and I draw these on this for the r of x, I know it'll never touch the x or the y-axis, and I know it'll never touch the x-axis. And that's true for what this graph looks like. I also know that the graph cannot be in quadrant 3 and quadrant 4 because the output will always be positive. How do I know that my output will always be positive? Because anytime you square something, if you put a negative in, when you square it, it's going to end up kicking out positive. And if I always kick out a positive, my y values are always going to be positive, which are up here. So the only places that y are positive are in quadrant 1 and in quadrant 2, so they know that it won't be in 3 and 4. So right here, they just fill in these tables again. This is the same exact thing that they did up there, but they actually showed you the tables, so you can pause your video and fill these in. All they're doing is they're taking this x, and for here, they plugged it into this equation. So when you plug in a negative 1 squared becomes a positive 1. 1 over x squared, they then took this x, negative 1, and plugged it in here. And when you put 1 over a negative 1 squaring it, you get 1 over 1, which is equivalent to 1. So that's how they filled in all of these values here, 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 and for the rest of the chart. All right, so complete that table. Now plot the points, and they see the graph. So they've got that. There's the graphs for you. And it says right here, does the shape of 1 over x squared, how is it similar to 1 over x? Well, the shape looks like their parabola split into 2. And they're turning away from each other. It's similar because they're asymptotes at x equals 0 and y equals 0. They're different because there are no negative values. So if you look before, it was my other one looked like this, where there was 1 up here and 1 over here. They were in opposite corners of each other. Whereas this one, they were both positive, so they were here and here. I'm going to make some conjectures about that later on. Alright, describe the domain and range. Domain is, well, what can my x be? If I look at this thing right here, we're talking about these guys. Can this thing go left forever? Yes. Can it go right forever? Yes. There's only one problem. It's not allowed to be 0. So you'll see there in the domain that they say, it's everything except it can't be 0. Same thing for the y. Describe the end behavior. Well, as x is going to negative infinity, or as x is going left, my y approaches 0, which means it's just getting closer to 0. As it goes to the right, my graph again is approaching 0. Alright? Describe horizontal and vertical asymptotes. We got x equals 0 and y equals 0. We talked about why those can be there. And so they go and they say, explore the graphs of 1 over x to the second, x to the fourth, x to the sixth. All even functions, this is going to be all even powered functions, will look relatively similar to each other. The graph will become steeper as the exponent gets greater. So it'll just instead of going like that, it'll be straight more like that, whereas another one will be more like that. So that's what they're talking about, steeper. More straight up and down, and the angle is real tight in here, whereas the other one might be a little more gradual, kind of like that. Alright, the domain will always be all real numbers, excluding 0 for x. The range will be all real numbers, except for 0, because, the range will always be all real numbers greater than 0, because y cannot be 0 or negative, because every time I get an even power, it always kicks back a positive number, so my output will never be negative. Alright? So here's some conjectures that we need to, these are important, and these guys are important. All odd powers will look relatively similar to each other. The graph will become steeper as the exponent becomes greater. The domain and range will always be all real numbers excluding 0, and the asymptotes will always be x equals 0 and y equals 0. Alright, last thing that's probably going to be the most important thing, and then like I said, tomorrow you're going to do some practice on this, so it'll hopefully make it a little more real as you're trying to come up with this stuff. So here's what happens. As I have evens, you need to fill in this chart. Evens, the range will be all real numbers greater than 0, because I know that my output will always kick out a positive number. So if you remember, the evens will look like this. My y values, y is up and down, my y values will always have to be up, because I have 1 over x squared. The squaring will, if I put in a negative, will always kick out a positive. So it's always going to be, my y values are always going to be positive. So that's what this is saying. graph only exists in the first and second quadrants. This is the first quadrant, this is the second quadrant. Alright, they both, when this overlap right here, that means they both have this, even in odds, both have vertical asymptotes here, both have horizontal asymptotes here, and the domain is all reals excluding 0. That means your x values are all reals except for 0. And your range here is all, for odds, are all real numbers excluding 0, because remember this graph looks something like this. And so you could have y's up here, you could have y's down there, so your y values could be positive, or they could be negative, depending on where you're looking, but they cannot be 0. That's that asymptote that's happening right there. And a graph could be any of the quadrants. So actually it could be in this quadrant, could be in this quadrant, this one, and so we'll study that more as we get to this. Alright? That's it.